everyone, I am A. Gayatri Acharya, Assistant Professor in CSC Department. Welcome you all to my video creation activity based on operating system. The topic of this video is logical and physical address. An address generated by the CPU is called as logical address, whereas an address seen by memory unit is called as physical address. Memory unit is the one which loaded into the memory address register of the memory. The compile time and load time address binding methods generated identical logical and physical address, but the execution time and address binding scheme is different for logical and physical addresses. Let's see how it works. Here, the logical address is referred to as virtual memory. Set of all logical addresses generated by a program is called logical address space, whereas set of all physical addresses corresponding to these logical addresses is known as physical address space. The runtime mapping from virtual to physical address is done by a hardware device called the Memory Management Unit, MMU. Mapping with a Memory Management Unit or MMU scheme is a generalization of base register scheme. From this diagram, you can see that the base register is now called as relocation register, and the value in the relocation register is added to every address generated by a user process at the time it's sent to memory. If you take an example, if the base is 24000, then an attempt by the user to address location 0 is dynamically relocated to the location 24000. That is, an access to the location 446 is mapped to the location 24446. The user program never sees the real physical addresses. The program can create a pointer to location 446, then store it in memory, then manipulate it and compare it with other addresses, that is, all as the number 446. The memory mapping hardware converts logical addresses into physical addresses. There are two types of addresses. Number one, logical addresses, which ranges from 0 to maximum value. Number two, physical addresses, which ranges the base value of r plus 0 to the base value of r plus maximum value. Logical addresses must be mapped to physical addresses before they are used. A logical address space that is bound to a separate physical address space is central to proper memory management. The entire program and all data of a process must be in physical memory for the process to execute. So, the size of process is limited to the size of physical memory. So, there is a question arise, how can we get more memory space for utilization? Think for a moment and write the possible solution in your notebook. Pause the video right now, and when you are ready, you can click the play button. I hope you have noted down some solution. So the solution is dynamic loading. It is used to obtain better memory space utilization. Loading means load the program or module from secondary storage device, that is, disk to main memory. There are two types of loading. Number one, compile time loading or static loading. Number two, runtime loading or dynamic loading. In static loading, all the routines are loaded in the main memory at the time of compilation, whereas in dynamic loading, the routines are loaded in the main memory at the time of execution or running. In this case, a routine is not loaded until it is called. It means, let me give you an example. Let's say a program occupies 1 KB in secondary storage, but it occupies hundreds of KBs in main memory, because some routines and header files should be loaded in main memory to execute that program. Generally, this loading is done at the time of execution. All routines are kept on a disk in a relocatable load format. The main program is loaded into memory and is executed. When the routine needs to call another routine, the calling routine first checks to see whether the other routines has been loaded. If not, the relocatable linking loader is called to load the desired routine into the memory and to update the program's address tables to reflect this change. Then control is passed to the newly loaded routine. The various advantages of dynamic loading are: unused routine is never loaded, large amount of code are needed to handle, and it doesn't require special support from the operating system. Thank you.